I'm Tim Barkley with Charleston Home and Design Magazine, and we are talking with Brian Mills with Mills Brothers Heating and Air. How you doing, Brian?
Good. How are you, Tim?
Doing great, thank you. Tell us about the project that we're going to be talking about today.
This is the Ward residence in Monk's Corner. We got the plans for this house a couple years back. We did a heat load calculation on it to properly size the HVAC. And we started speaking with Todd about doing the spray foam in the attic to help condition the space, to lower the size of system we need, to lower the energy bills ultimately once the system was installed, and then to ensure longevity for the product so that we wouldn't be sweating and tearing up the ductwork in the unit.
What is a load calculation?
Basically what we do is we draw the house on computer, taking into consideration all the building materials, and that gives us a tonnage, an equivalent in tonnage or BTUs that the house is going to need to either heat or cool it.
And you're using different mathematical calculations and taking into consideration the different building materials that are used on the house. How does that differ from how load calculations to determine the size of an HVAC unit were done in the past?
Basically, it was kind of a rule of thumb, and each contractor had his own rule of thumb. And the problem was different building materials would either allow heat in or out. Those rules of thumb would fall to the wayside or wouldn't work. Ultimately, it'd be discomfort for you. Now, with knowing the basically molecular makeup of a product and how it allows heat in or out, we can then determine what size we need more scientifically, if you will, and properly size the equipment for the house to ultimately ensure cheaper electric bills.
Now, in this house, how many square feet is this house?
It's a 3,200 square foot ranch, single floor with about a 2,000 square foot attic that may be turned into some other rooms later.
And I guess I'm venturing a guess here, but it seems like the higher the tonnage unit, the more expensive those units are.
That's right. What we try to do is when we do that heat load calculation, most of the time you're going to get an equivalent price in tons. So we say, hey, yours is X amount of price per tons. If we can shave a ton off the house's load by using better windows or spray foam, then basically you take that money off that ton and you put it into those materials. So if you have a $5,000 or $6,000 quote to do, say, an attic line, if ours is $3,000 a ton and we give you a ton back, now you're only looking for about $3,000 to spray foam, whereas a lot of guys' rule of thumb still put in the same size equipment, and then your $6,000 is still the price. If you start working the building science together, you're able to shave some off of what we do by putting it into a product that does better for the energy.
Now, Mills Brothers Heating and Air, you folks do not sell spray foam or anything like spray foam insulation or any other kind of insulation?
We actually sell some mobile jugs if we need on smaller projects, but for the most part, we sub this out to a spray foam company. It's easier for us. They do what they do. We just incorporate it in. And as a contractor, licensed state contractor for mechanical work, this becomes part of kind of what we do as a complete system, if you will. And if you spray foam and use the system with our units, it becomes a complete system mechanically for the house.
Well, I guess I was just trying to get at the motivation, because it seems like if you can sell a higher tonnage HVAC unit to a customer, you're going to make more money, and vice versa. If you're telling them to spend money on insulation and therefore they're buying a smaller ton HVAC unit from you, you're not making as much money. So that doesn't really, it almost seems like you're one of those honest contractors out there, huh?
Well, definitely it does make our product work better, and ultimately if the customer's happy, the energy bills are low, we've done our job, we get more work in the future. We're not trying to pay all our bills off one customer. We're trying to build a base of customers, and by using this product, our equipment works better and lasts longer, so then our customers trust us better, and we get more work from that a lot better than we do the other way.
Well, and then I guess what comes to mind is, well, if the units are lasting longer, then that's less money in your pocket in the future too.
Well, once again, we're trying to do a better quality product, and we're not the cheapest. If you get a bid from us, we're not going to be your cheapest guy. We're not your most expensive guy, but what we're trying to do is a good quality product for a fair price and something that really works for you and the building science of the house and ultimately lowers the energy bill. And we may be taking a little bit out of our pocket, but I think we'll make it up in the long run.
So Mills Brothers Heating and Air is taking you approach a project by looking at the house system wide then.
Right, building science, if you will, and based off of Emmanuel J. through Rightsoft. They're a company who sells programs to do that, and they look at the house's structure, and as a building science collectively, how will the system work with the house, where it's placed, what city, town, what materials we've used to build it with, windows, down to everything we put in there, how many fireplaces, and et cetera. And we really do a pretty good bit of work to get that together, and it's really accurate in the long, and by the time we're done over the long haul, it's really accurate.
Are there still HVAC companies out there who are using their own rule of thumb to determine load calculations, maybe the size of the rooms or the number of rooms on a floor, that kind of thing?
There are, and you know, the rule of thumb works probably half the time, but on either extreme, be it winter or summer, the rule of thumb starts to fall out the window. And if it's colder than we expect it to be, or hotter like last summer than we expected it to be, then the unit starts to struggle, or it starts to lose capacity or efficiency, maybe sweats too much if it's a high humid day. And with the heat load calculation, we take that into consideration. And really the only way to guarantee around the main problems is to better insulate your product or encapsulate where your product is going to be, so you can control the environment around the ductwork and not try to control the weather.
What happens if a house does not have a properly sized HVAC unit? If it's too big, it's too many ton unit, or it's too small?
Too small is going to be obviously lack of capacity. Too large is going to short cycle. You're going to stop start every few minutes instead of running for a length of time. To put it into layman's terms, maybe a car. You wouldn't turn your car off at every stop sign. You would drive that car until you were done, reach your destination, turn it off. That's what we want our units to do. They should run on the hottest or coldest day 16 out of 24 hours. If they're too large, they're going to turn off, turn on, turn off, turn on. Those start components are going to end up going bad. You're going to have higher cost on maintenance in those products, or even longevity. They may not last as long.
Now, Brian, you had told me that it's very, very important that ductwork in the attic, or if ductwork is run underneath the house, that it's very, very important that ductwork is in conditioned space. Tell our listeners and viewers about that.
As we were talking about lack of capacities and on the extremes of the weather cycles as we get them, if your ductwork is in conditioned space, we can control indoor air quality issues like mold due to sweating. If we're dehumidifying that area, we can control that. And then if it gets too hot or too cold, we don't lose capacity. For example, in the summer, we probably lose 30% capacity on a unit if it's in an attic with unconditioned space. So if it's just a vented attic and it's 140 in your attic, you're losing about 20% of capacity. If you needed all 3 tons to cool your house and you're losing 20 or 25%, now you're not comfortable. Now we're not reaching that set point on the thermostat. With encapsulating the space, we can start to guarantee comfort, indoor air quality, and those issues don't get paid for in the energy bill. So you can't look at your energy bill automatically and go, well, it doesn't pay for itself. Comfort and indoor air quality is person-to-person priced.
Now, if this particular house has how big a unit, and what's the brand on that?
We did because of the length of the house. We did 2 units, one for the master kind of suite in its area, and then one for the main living. They're 2 3-ton 2-stage. So when we need the oomph on the extremes of the weather cycle, we have it. And when it's nicer spring and fall, we're able to throttle our systems back to a 2-ton or 2.25. It's 67% of its capacity, and that allows us to run lower energy bills as well. And there's 2 of those in this house, 2 3-ton 2-stage systems, Heil, They were tax qualifying units when it was the incentives were there.
What is a two-stage unit? What does that mean?
The compressor has 2 stages of capacity, either 100% or 67%, and we call it first and second stage.
So if it only requires it to run on the second stage, then it's using less energy then?
Yes, it's using less energy, about 2/3 of its capacity to run and to be able to condition the home. And in a home like this, for the most part, unless the differential, meaning what you're asking for on the stat versus what it is, if it's within the 3 or 4 degree range, 90% of the time we're running on the second stage.
And what SEER is are these units?
These are 16 SEER 2-stage.
So 16 SEER, that would be a high efficiency unit?
It is, yes. It's high efficiency with what people are becoming more familiar with called variable speed blower motors. So we can adjust airflow for noise, another indoor air quality issue, if we need more capacity somewhere. And then it's good for varying for dehumidification. If your unit has dehumidification capabilities, it can speed up and slow down the fan to help dehumidify better.
And back to the running the ductwork in unconditioned space. What can happen if people have their ductwork either under the house in unconditioned space or up in the attic and in unconditioned or uninsulated space?
Well, loss of capacity probably being number one, or maybe indoor air quality, and especially with mold. In our area, we have humidity.
What happens on a hot summer day to the ductwork when it's exposed to that humidity?
It begins to sweat, just like a cold glass of sweet tea or water would sweat. So does the ductwork. And then as it sits under that house in a dark, damp, moist environment through the evening, it begins to grow mold. And that system takes place from probably April through October in Charleston.
And that mold and that humidity, what's the effect on the homeowner and on the home itself?
Well, you see a lot of wood movement in a lot of humidity under homes, floor joist movement, hardwood floors buckling, and then for the indoor air quality for the homeowner and the people in there, the mold being kind of just distributed evenly throughout is a bad indoor air quality, especially people with allergies or asthma. It really affects them in a negative way.
Okay. Is there anything else you want to add about this project in particular?
This is one of our success stories. We've got an energy bill last July of $137 for a 3,200 square feet home with a 2,000 square foot attic. Our attic is maintaining same temperature and humidity as the living space. And as doing the heat load calculation and doing this system right, I think it just shows that this is the new and upcoming way to look at your house and make sure that you take care of it for the long road and not just as I tell Paige all the time, not just buy the granite and the stainless and the countertops, but actually look into the more important features of the home that we don't see every day, but just like a car, the motor and the transmission of the house, the mechanical systems, and how that's going to affect the home over the long haul. Because once the paint fades, it's a comfort issue. How comfortable is our house? And without properly sized heat and air systems and building science of the home, the discomfort becomes a main, it's our number one problem as we go and retro people's homes.
Well, not just the physical discomfort, but also discomfort by having to pay higher bills too, right?
That's right. To fix it, always fixing it after the fact is going to cost more than doing it up front. There's things, by the way, we've done this system that you can eliminate.
What this is new construction, but can our listeners and viewers get the same kind of result if they were in an existing home? Is there a way to retrofit it?
There is, especially in the exposed areas. Obviously, vaulted ceilings, cathedral ceilings, places where you have drywall and we can't get behind, it's hard to do the spray foam. But in areas where you have an open access attic we can encapsulate, you can get the same effect of energy bill through the reduction in energy bill by doing it in the retro.
Well, tell everybody how they can get in touch with you at Mills Brothers Heating and Air.
Our phone number is 764-1919, and you can find us on the web at millsbroshvac.com or find us in the Charleston Home and Design magazine.
Okay, good deal. Well, we have been talking with Brian Mills with Mills Brothers Heating and Air. Thank you, Brian.
Thank you.